Students, today I have discussed the remaining part of the preparation of alkyl halide, reactivity of alkyl halide, and the last is the elimination reaction. Now in my next lecture I will tell you what are the SN reactions. This is the remaining part of the alkyl halide. I hope you will understand all the parts of alkyl halide. Thank you.
As a result of this, here is one chlorine is attached to form the alkyl halide and remaining byproducts are formed. POCl3, 1H makes a ACl. POCl3 and ethyl bromide is formed. Next is action of thionyl chloride. This will be also same. For example, here is again alkyl halide, ethyl alcohol plus SOCl2 in the presence of pyridine. This is not a catalyst. This is used as a solvent. So what happened? The same result, ethyl chloride is formed with the gases sulfur dioxide and the HCl as a byproduct. How they are formed, the mechanism and the concept is the same. Here is the polarity arise and the when the SOCl2, that is called as the thionyl chloride, when attacks Cl makes a ethyl chloride and the oxygen attacks with the S double bond O and forms the SO2 and the result is the ethyl chloride. So the mechanism are the same. Next most important method is mostly alkyl halide is prepared from the alcohols. The result of these reactions are that mostly alkyl halide is prepared from the alcohols. Reagents are changed, halogen acid, SOCl2 and PCl3, PCl5 all are the used for the preparation of alkyl halide. One of the most important reaction is halogen exchange reaction. For example, here is the ethyl. Alkyl halide is used as a reagent for the preparation of another alkyl halide. How is it formed? For example, here is the ethyl bromide. When you react it with sodium amide in the presence of pyridine, what happened? Ethyl iodide is formed. This is mostly used. For example, alkyl iodide is not prepared directly. So this reaction is very important for the preparation of the ethyl iodide. Next topic is that these are all the preparation of alkyl halide. Reactivity of alkyl halide depends upon the two factors. One factor is the bond energy and other factor is the bond polarity. First of all, what is the bond energy? Energy need to break this bond, Cx, or energy release in the formation of this bond, Cx. So this is called as the bond energy. For example, you know, if there is Cf forming other bond, Cf, Cl, Cbr, Ci. How do you explain the bond energy of the carbon fluoride? 467 kilojoule per mole energy is needed to break this bond. 346 are needed, 296 are needed, and the lowest one is the 228 kilojoule per mole energy is needed to break this bond carbon iodide. So less amount of energy is needed to break this bond, so they are more reactive. What are the criteria? How do you explain the strength of the bond? Ri is greater than RBr in the sense of reactivity. I am going to tell less energy is needed to break this carbon iodide bond, so these are more reactive, and carbon iodide is more reactive than RBr. RBr is more reactive than RCl and RF. So RF is in the case of carbon fluoride more energy. 467 energy is needed. It's too much, so it's not reactive as the other members. So first thing is that. Second is the bond polarity. If you are going to discuss the bond polarity means it arises bond. What is the polarity? Polarity arises due to the difference of electronegativity. For example, chlorine is the more electronegative, has the electronegativity 4, chlorine has the 3, iodine has the 2.5. So difference of electronegativity shows the bond polarity. If there is a more difference, it's more polar. For example, if the F is the 4 and the carbon is 2 point something, so difference is more. So these are, in the case of the bond polarity, you can say it's more reactive. Carbon F bond is more reactive than the carbon chloride is more reactive than iodide. So most of the reactive in the term of the bond polarity and the more polarization is the CF. So it's more reactive. How it's more reactive? So what the reactions will be decided. In the case of bond energy, carbon iodide is more reactive. In the case of the bond polarity, carbon. But the bond energy is the factor which decides the criteria for the further reactions, not the bond polarity. So as a result of this, we can say bond energy decide which one is more reactive.
Assalamu alaikum, dear students. Today we are going to discuss another topic of chapter alkyl halide for second year class. The topic is called as the elimination reaction. In the last lecture about the nucleophilic substitution reaction, I have told you about the nucleophilic substitution reaction. The attacking nucleophile attacks the electrophilic carbon. You know, substrate is alkyl halide and the attacking nucleophile attacks on the alkyl halide. As a result, substitution product is formed or nucleophile is substituted with the bromide ion. In the alkyl halide, there is another side for the attack of nucleophile. Which one is this side? Question arises. One side is that one bromide ion is replaced with a hydroxyl ion, or you can say nucleophile, and as a result of this, substitution product is formed. At the same time, some other reaction is also done. How is it performed? For example, look at this primary alkyl halide. That is called the alpha carbon. The carbon which is attached with the halogen group is called as the alpha carbon. And the carbon adjacent to alpha carbon is called as the beta carbon. And the beta carbon, the hydrogen bonded to the beta carbons are called as the beta hydrogen. So during these reactions, when the nucleophile is available at the same time during the nucleophilic substitution reaction, at the same time hydroxyl group attacks on the beta hydrogen that is electrophilic. As a result of attack of OH group on the OH, that is I have circled, that hydrogen releases the electron, and electron shift to the center of these two carbons. As a result of this, instead of the substitution product, double bond is formed, and at the same time bromide or halogen group leaves out. So this is called as the elimination reaction. Elimination of what? At the same time hydrogen is eliminated and the bromide, that is called as the bromine, leave out. So we can get an alkene instead of the substitution product. Such a type of reactions are called the elimination reaction. Sometimes these reactions are taking place simultaneously with the substitution reaction, and sometimes elimination reaction have a competition with a nucleophilic substitution. Now, I think in the same manner as you have read about the SN1 reaction, SN2 reactions, there are two types of reaction, E1, E2 reactions. For example, what is the E1 reaction? Same as the, first of all, I am going to look at this. Here is the nucleophile B. It shows B, which attacks on the electrophilic hydrogen, that is called as the beta hydrogen, and X is leave out as a result of the double bond is formed, right? Now, first of all, I am going to discuss the E1 reaction. What is the E1 reaction? Same as the SN1 reaction, unimolecular elimination. Two groups are lost, halide and X minus in the nucleophile act as a base, and it's the same as why it is called as the E1 reactions, because the reaction depends upon the rate law depends upon the concentration of the one molecularity and order of the reaction depends upon the one compound. So look at this. What is the mechanism? This is even mostly used for the tertiary alkyl halides. This is called as the tertiary alkyl halide. First step is the same as slow step, and the ionization takes place, and the tertiary alkyl halide forms the carbocation bromide in the first step. leaves out, and as a result of this, carbocation is formed. Carbocation is formed and bromide is leaving out. So in the first step is the slow step, so it's the rate determining step. Second step is the fast step, when the hydroxyl group or nucleophile attacks on the beta hydrogen. This is the alpha carbon, carbocation, from where this bromidine leaves out. And second carbon look at this. Second carbon is the beta carbon, and this is the hydrogen. A nucleophile attacks on this electrophilic hydrogen, and hydrogen releases electrons, which goes showed by this arrow to this center of the carbon atom. As a result of this, carbon double bond carbon is formed, and this hydroxyl group takes the water on, and hydroxyl group takes the hydrogen and form the water. So this is the two-step reaction. Even first step is the slow step, so it's called as the rate determining step. And chemical kinetics, which I have told you in the SN reactions, depends upon the concentration of this reactant. So this is called as the E1 elimination reaction, and eliminating product is H and the Br here. Next is the E1, and next is the E2 bimolecular reactions, single step reactions, and requires the strong nucleophilic reagents and happen simultaneously. For example, here what happened here is for example, another hydroxyl group or nucleophile attacks on the electrophilic hydrogen atom. At the same time, this electron shifts between the carbon and carbon bond. As a result of this, carbon double bond carbon is formed and bromide leaves out. So as a result of water is formed, bromidine is leaving out, and double bond alkene is formed. So this is called as the single step reaction. At the same time, bromide leaving in and then at the same time, nucleophile attacks on the electrophilic carbon, and bromide leaves. So this is called as the single step. And reaction kinetics depends upon this is the slow step, this is the rate determining step according to the chemical kinetics. So rate of the reaction depends upon these two reacting molecules. One is the nucleophile, other is the alkyl halide. So you can say it concentration of the two molecules. So this is called as the E2 mechanism. So this is the basically elimination reaction, elimination of hydrogen and the elimination of the bromidine. These are taking place at the same time when the substitution reactions are performed. Sometimes both the reactions compared to each other. This is the comparison between the E1 and the E2. One thing that is tertiary, this is E1 used for the tertiary, E2 used for the secondary, and the primary, this is used for weak base, this is used for strong base. And reaction kinetics I have already told you. This is all about the elimination reaction. This is same as an SN1, SN2 reaction. Difference is that in the nucleophilic, try to focus on the difference. In the nucleophilic substitution reaction, nucleophile makes its room on the alkyl halide by the replacement of the bromide. You can say it replaces, so it's substituted, hydro OH group substituted and leaving the halide. In the elimination reaction, it eliminates the hydrogen and the bromide. As a result of this, alkene is formed. So that's all about the elimination reaction.